All right. Any questions? Come on. Okay, so let's get started. First things first. Turn to the person next to you. Say your name. Say, I guess, your background with coding and what you ate for lunch today. All right? So take a couple minutes. Meet the person next to you. On a scale of thumbs up, I have a lot of experience with GraphQL. Thumbs down, I have zero experience. Show me where you are with GraphQL. All right, that's pretty good. This is an introduction, so we're going to start there. So by the end of this, I have a couple objectives. So number one, know the difference between REST and GraphQL. REST is the structure that most people probably know for API design, and what the benefits of using GraphQL are. There's also some cons, but we'll talk mostly about what the differences are. There's a few parts of GraphQL I want to make sure that you understand by the end, which are queries and mutations, schemas and types, and then also resolvers. And quick interjection, if I talk too fast, just do this and I will slow down. I'm a very fast English speaker and I'm working on it. This is just an introduction, but this is API architecture philosophy that's used at a lot of different companies. I actually used it at my last company. We migrated from REST to GraphQL in our gateway layer while I was there, and definitely saw some interesting things in that transition. So, first question, what happens when you press submit? So you're on a website, there is a form, you fill it out. What happens when you click submit? Talk to the person next to you. What do you think happens?
I wouldn't send passwords in email. I would register them.
All right, take about 10 more seconds.
I don't know. If we had a very RESTful architecture, I think it is
Okay, so if you understand how pizza is made, you probably understand how server architecture works. So my favorite metaphor is pizza, partly because I'm always hungry, but also because I spent a long time working in restaurants. And when I first got into software development, I didn't really understand the difference between the front end and the back end. But I had worked in a kitchen, so I knew the difference between a waitress and a chef. So this is how it works. So if you're in the front end and you have the client side, you need to get things from somewhere, right? So can someone tell me what they think happens when they press the submit button? Did anyone come up with a good answer? Yes?
Yeah, it depends if JavaScript is involved. If not, the action attribute of the form element request will be done. Usually post, but depends.
Yeah. So you click something, and then in the background, it ends up sending a request. And so usually in architecture, we've got three major components. We have the client, we've got our server, and we've got a database. The database is usually not in the server, but it's connected to it. And so in your client, which is your front end, you make a request, and then you send something to the server and say, I need ingredients back. So it's a lot like building a pizza. I need ingredients, I go somewhere to get it, I say this is what I need, I end up getting it back. So what happens when you press submit? So there's three terms that we like to reference. There's the HTTP methods, there's API endpoints, and then there's the server interaction. Right now, write down as many HTTP methods as you can. If you don't know any, that's okay. All right? Write down as many HTTP methods as you can. Which ones do you know? All right, who has an HTTP method? Raise your hand. Yes, what do you got?
Oh, put.
Put. All right. What does put do?
It usually like replaces something.
Yeah. All right. What else we got?
Post.
Post. What does post do?
Update the database.
Yeah. So new information in our database. All right. What else? Yes.
Get.
Get. What does get do?
Mainly fetch some data from database.
Yeah. Get gets things. Good. What else? Yes.
Delete.
What does delete do?
Delete.
Yes. All right. What else?
Head.
Which one?
Head.
What does that one do?
It's like get, but if it's the same as before, then it only returns the headers, I think.
All right. What else? Yes.
Options.
What's that one?
Just gives you some information about the server capabilities.
Yeah, so there's a lot of different methods. What does HTTP stand for? Does anyone know? Yeah.
Transfer protocol.
What is it?
Hypertext transfer protocol.
Hypertext transfer protocol. Okay, so an HTTP method is sort of like an action. It's a verb, and it's what we tell our server what we want to do. So we want to get something, we want to post something, we want to put something. Also in our normal REST architecture, so our normal architecture of how we interact between the client and server, we have an API endpoint. So this is the URL that we send this method to get information back. And so in this example, we have API in the beginning, that's the beginning of our string, and then we have ingredients. What do you think this method's going to do? We're going to get the ingredients. So here's some other ones. Post, that would be add new ingredient. Put, that would be update ingredient. What do you notice about put and delete that are different? Anyone? Yes?
It's got that third, it's got an ID.
Yeah, it's got an ID. Why do you think we need an ID for these two?
In order to define the target?
Yeah, in order to define the target. So all the other ones, we can just send information or get information. The second two ones, we're getting and sending information for a specific thing. All right, so this is our normal structure. So this is how it ends up being a problem at a company sometimes. So if you're working at a company and you have front-end engineers and you have back-end engineers and they're working together, the front-end might have something that they need. And they'll say, okay, I need this endpoint, and I'm making vegetarian pizzas, and I only need the name and the price. And then the back-end person is like, okay, I can get it to you, but currently the data object has all these other things, so why don't you just filter it on the front end, and I've got like 5 other things on my plate, so wait. Does that sound familiar? All right, so here's the difference with GraphQL. Instead of having the back end and the front end having to work together, you put a middle layer in between. So the front end can query for whatever they need. And that filtering happens with the query that they send. So GraphQL is a query language, so GraphQL, query language, for the front end. So your front end team would write queries very similar to SQL to get information that they need. So, in REST, our normal architecture, API routes on the front end have to match the back end, and collecting any information from the database requires input from both teams. So both teams have to work together on this. GraphQL, you set up all of the structures and the schemas ahead of time, so then once it's set up, the front end can control what types of queries that they ask for. So that's the benefit. It just kind of pushes that responsibility more to the front end. It still requires both teams to work together, but a little bit less. So if we're going back to our pizza metaphor, if I need to get ingredients in a REST architecture, I might say I need tomatoes, I need pizza crust, I need chicken, and I need cheese. And I request it, but I get back tomatoes and peppers and carrots and pears. I'm not sure why that's in the veggie thing, but I get back lots of things. I have to filter it on the front end. With GraphQL, I've got something in the middle, and I'm basically handing my instructions to someone who's going to drive his truck to all the different factories and pick up what I need and return what I need. All right, so this is a very high-level metaphor of it, but that's essentially what it is. Okay, I'm going to leave this up for a second. With the person next to you, try to repeat what we just talked about, all right? Actually, let's do it this way. Draw a line in the middle of your whiteboard right now. Yeah. And on the top part of the line, I want you to write what I learned, or what you already knew about GraphQL, that's fine too. And on the bottom, questions I have. Okay? So with your partner, on your whiteboard, write down what you learned together and questions you'll have at the bottom. Take about 2 minutes. Partner exercise, you have to talk to each other.
always get I think you can make a very change.
I want you to save your questions. We're going to keep going over the architecture, and then I'll take more questions at the end. But just hang on to your questions for now, because the ones I was hearing, we are going to be covering a lot of them. So the difference. All right. So here, let's dive into what it actually looks like a little more. So in REST, you use HTTP methods. You have API endpoints, and you structure those the way that you want to get information. So you choose your method and your endpoint based on what you need. In GraphQL, there is only one endpoint and one method that you use. So you only use post ever, and you only use the endpoint GraphQL. The reason for this is you are posting instructions to that endpoint of GraphQL. So in this previous example, the routing happens on the server side to decide where you're going. In this example, you are sending it straight to GraphQL, and GraphQL ends up doing, it's kind of the middle layer between everything else. All right, so you post instructions. All right, let's dive into what the server setup looks like. So this server is built using Node and Express, and let's walk through each line of the code. So first, we're going to create our server. So if we look at our code, at the very top, we're requiring Express. At the about halfway through, we're saying var app equals Express. So this is where we're creating our server and we're running it. App.use, we're passing in information into our Express server, and app.listen means we have it on 4000. So if we were to call this endpoint, it would be localhost 4000/GraphQL. Okay? Thumbs up on understanding that part. All right, cool. So now we've got a server running, and now we want to start using GraphQL with it. So at its most basic structure, we really only need, I guess, 3 things. So first, we need to actually bring GraphQL into it. So here we have GraphQL HTTP requires Express GraphQL. And as an argument into app.use. So app.use is a function that takes 2 arguments. The first argument is a string /GraphQL. That tells us that we are running our server with that as the endpoint. The second argument is the function GraphQL HTTP, which we pass an object three things. The first thing is our schema. The second thing is our root. And then the third thing is optional, but I recommend you always is GraphiQL and set it to the Boolean true. So let's back up. So where'd my go? Okay. So if we're setting up our server, we need to pass in our root, which is our resolvers. We need to pass in our schema. And then the last thing is GraphiQL to true. And so what GraphiQL does is it sets up an interactive playground which we can play, we can test all of our queries in. All right? So this is optional, but definitely recommend it. All right, so let's go back to our code. So we're passing in our schema and we're passing in our root. Here's where we need to create our schema and our root. So our schema is the way we expect the data to be structured. Our root is where we decide what a request would send back. So let's get into that. All right, so our schema, we're going to build this schema. So if we have, let's see here, if we have people in our schema, our people might have IDs, they might have names, they might have gender, there's a few things. So if we're building a schema for people, that would go there, and we'd not only need to say what that key is for each of those, so person or name or gender, we'd also need to say what the data type is. So I'll show you an example in a minute, but name would be a string. ID would be an ID, for example. All right, so our root resolvers, this is where we navigate what we need to resolve. So if we were saying get person, and that was one of our queries, inside of our resolver, we would create a function that would return person or return people. And then again, GraphiQL to true, that sets up our interactive playground. We would find that interactive playground at localhost 4000 GraphQL. Okay, so this is what a schema looks like. So in our schema, kind of like what we talked about before, you have a certain type. So instead of a person, in our pizza example, we might have a type for ingredients. And ingredients might have a name, they might have weight. If it's vegetarian, maybe it's a Boolean. So here's an example of the structure for ingredients. Then, at the most basic level, we definitely need to have a type called query. All right, so you need at least the type called query, and then within query, you're mapping it to all your other types. So ingredients is a type for the structure of the data. You at least need to have type query and pass in the types of data that you would get back. And we'll have some examples. What's the exclamation mark for? Yes?
Required fields.
Require fields. Yeah, so if your ID is required, give it an exclamation mark and it'll throw an error if it's not there. So some of our examples of types of data you might have are strings, integers, floats, booleans, IDs, the normal suspects. All right, this is what the resolver looks like. All right, so in here, we just create functions that return the data that we need. So if we were mapping this to our database, this is where we would do this. This is where we do the database call, or we call another utility that would call our database. So if we have a function called query ingredients, that we want to return ingredients, this is where we would end up going to our database to get that information. What's really important is that you need to be able to match the names of the types included in your query and mutation to the types in your schema. So let's go back a level. We have a type called ingredients here. In my resolver, I expect to have a function named ingredients. And that ingredients function, I expect to return name, weight, and vegetarian. You do not have to filter information out here, because when you're making the query from the front end, if you only want to request the name and the weight, you just say query ingredients name and weight, and it will not return whether or not it's vegetarian. So that's the big difference here. Return all the things here, and then in your query from the front end, decide what you actually want it to return. Any questions on schema or resolvers? Okay. Cool. So again, this is what it looks like from the front end. So my front end, I am posting to the endpoint GraphQL. I'm posting because I'm posting instructions. Whether I'm getting information, whether I'm sending information, doesn't matter, it's instructions. And what that looks like is I just send a string with this information, query, ingredients, name, and price, to post GraphQL. And then what ends up happening is I get back all the ingredients with their name and their price, despite the fact that in here I also have weight and vegetarian. This should also say price. It's going to give me an error if it's not included in the schema. All right, so I'm calling post. It goes to GraphQL. I sent those instructions, query, ingredients, name, and price, and then what I get back is all the ingredients and their name and their price. So that's on the client side. This is what it might look like in the code, for example. So again, I'm fetching using the method post. I'm sending that query to that endpoint, and then I should be getting back that data. If you are setting up a front end, which we won't be doing during this workshop, I recommend trying Apollo Client. It's if you're using React, it's a higher order component that wraps around everything and makes it a lot easier to interact with. Again, why post? Because you're posting instructions to GraphQL. I'm going to keep saying that because that's where everyone messes up the first time, because you expect it to be git or patch, or I guess probably not patch, most people use put, but everything else. So there's two terms in GraphQL language. We just saw query ingredients with name and price. There's also something called a mutation. So query, if we were to do query ingredients name and price, that's just for get. All those other methods that we talked about, not everyone we talked about, we brought up some random ones, but post, patch, put, and delete would be a mutation. So rather than saying something like query and then ingredients, I might say mutation. And then I expect it not to get information, but to post or put or patch. All right, here's GraphiQL. So this is, if you remember when we set up our server and we passed in our root and our schema and we set GraphiQL to true, what that ends up doing is creating this playground. So at the end of this lecture, we will be playing with either A, setting it up, or B, playing with the playground. So I've got two links here. The first link is a repo you can pull down and actually set up your server and test creating schemas and resolvers. The second one is one that is already set up for you. So this is actually a playground where you can test Pokemon calls. So GraphQL has three sections. The top left is where you would actually test the queries that you're writing. So if I set it up with my pizza example and I wrote in query, ingredients, name, and price, on the right side I would expect to get back all the ingredients and their name and price. On the bottom left is where I can pass in variables if I wanted to use variables instead of directly typing in things. The other thing that's pretty cool is on the right side, and I'll show you, there's actually documentation it creates for you. So you can see how you've already structured your schema before you start to play with it. Oh, okay. Let me quickly animate this. I don't want to show you all of them at once. All right, so we're going to do a quick pop quiz. All right. Question number 1. Your GraphQL server contains the following items. What do they do? All right, take 1 minute, try to figure it out with the person next to you. Your GraphQL server contains a schema with types and a root with resolver functions. What do each of those things do? Tell the person next to you. Alright, take about 30 more seconds and then we're going to talk.
Field of the request. So I guess the result of the final by name. This is strange. This is so if we need to write resolve for all kinds of filtering, for all kinds of search, we have like searching for name. As simple as the all the work. I mean, what if you wanted to search by,
Alright, who thinks they have an answer? What does the schema do? Yes?
Define the structure of data.
Yes, that's exactly it. It defines the structure of the data, which allows us to do better error handling. It allows us to make sure we're mapping the correct things. Awesome. What about the root with the resolver functions? What does that do? Yes?
Define the root point of the data, or scope of the data.
Yeah, so it defines the root point where we enter it. What do the resolver functions do? What does the word resolver mean? If you are resolving something, what do we expect resolve to do?
Returns the data.
Yeah. So resolve returns the data. It resolves our query. So if we are sending it a query, it resolves it for us. It gives us back what we expect, and it maps it to that schema. What are some of the types for your schema? What do you think? String. What else?
Integer.
Integer. What else?
Boolean.
Boolean. What else? What? Timestamp. I think so, yeah. What else? What? Text? Yeah, like string, yeah. What else?
ID.
ID? And float. Float's another one. How do you make a type non-nullable? How do you make it required?
Exclamation.
Exclamation mark, good. Okay, so what is a query and what is a mutation? Let me ask this more specifically. Which HTTP method is the same as a query? Get. Good. What about mutations? A lot of the other things, yeah. So put, post, patch, things that mutate the data. So query, we get it, mutate, everything else. Most things else. How are they similar to HTTP methods? We just shared. However, when you call a GraphQL query or mutation from your front end, what is the actual HTTP method and endpoint you use? Post. And what's the endpoint?
Single endpoint.
Yeah, single endpoint / GraphQL, which we set up when we set up our server, because we said app.use, and the first argument I took was /GraphQL. If you didn't do /GraphQL and you put in /BigBird, it would be /BigBird. So it can be whatever you want, but the standard way we do it is /GraphQL. Why do we do a post?
Post a query.
Yeah, because we're posting instructions. We're posting it. We're sending it. What might some of the benefits be of using GraphQL over REST? We kind of talked about that in the beginning. It does require more time to set up, but what might the benefit be?
Structured data.
Yeah, structured data, and your front end has control over what they request. A little bit more control than if you had to match up with the front end and back end team. Okay, let's get into it. So there's 2 different paths you can take for this. This bottom link is if you want to just play with queries, and the top link is if you actually want to build out your structure of an actual server. So let's start with the bottom link. I'm going to give you a quick dry run of both of them, and then it's up to you to decide how you want to do this with your partner. Before we start, I'm sorry, were there any questions on your whiteboard that I did not cover? Yes. All right. What?
I'm not sure that's the perfect time right now to raise them, but we were worried about performance compared to basically REST architecture. Just a quick question was that you can at the very beginning you compared GraphQL basically to querying SQL, and you can write absolutely terrible SQL queries.
Yes.
You can write shitty SQL queries.
Yeah.
And one of our questions was that can you write shitty GraphQL queries?
Yes.
You can. Brilliant.
Yeah. So performance, it's like anything else. It's abstracting some things away, and so because of that, I would say spend some time looking at some of the blog articles that are about that. If I'm writing a very simple application, I would not use GraphQL. I just don't think it's really necessary. It's faster for me to do REST. If I'm the only one developing, I know what I need to match. It's more when you get into teams that are very separated that I think the benefit comes up. So for us, like the reason we used it at my last company is our back end was in Python, our front end was in JavaScript, and these were very senior engineers who were very specialized. And I was actually the only person, I was very junior, but I was able to write both front end and back end Python JavaScript. So we moved our gateway into Node Express so that they thought the front end could help with it. The front end still did not help with it. And then once they moved it to GraphQL, the front end took responsibility for the gateway. So for us, it was a way to solve an operational problem, which I guess is every single software team anywhere. It's really about technical anything and more about people. Yeah. Other questions? Okay, feel free to pull me over as we work on these and ask me individual questions if you don't want to ask in front of everybody. So let's pull up this first link. Again, it's on the whiteboard. It's GraphQL-Pokemon.now.sh. And this was published by someone else. But I'll show you kind of how it works. So let me make it nice and big. So this is that interactive playground I talked about earlier. So someone else built this mini server for us to play with and published it, which is really nice of him. And on the very bottom, you see variables. This is where I'm going to pass them in. We're not going to. The top left is where I'm going to test my queries, and the right side is where it will display. So your question might be, how do I know what to type? Well, if the schema was set up for you already, and if the root resolver functions were set up for you already, you can click on Docs, and you will see what has been set up. So here it says root types. So it has a root type called query. If it was possible to mutate this data, you would also see mutation here. So if I click on query, it looks like I've got a couple different queries I can do. So let's start by writing query. I'm gonna make this bigger. Woo. And then query is an object. And then it looks like I can print Pokemons, which takes an argument called first. So I'm gonna type Pokemons, and then first, how many Pokemon should I get? 10? And then that is another object. Okay, so let me click on Pokemons and see what happens. So it looks like there are a few different fields that I can request. So in my schema, this means that I have a type called Pokemons. And all those different fields have been listed under that type, and here are all the data types they have been mapped to. That's kind of like what we talked about before. So from my front end, let's say I want to get 10 Pokemons, but all I want to get is their ID and their name. If I just want to get their name, I can't. Does anyone see why? It's a little hard to see. What's different about ID on here?
It's required.
It's required. There's an exclamation mark. So whether I want to or not, I have to request the ID. All right, so I'm going to type ID. I'm going to type name. And let's actually also do weight. Actually, I'm going to start with just ID and name. All right. ID and name. Boom. Okay? So I got back 10 Pokemon. I got their IDs and names. So this filtering happened for me. I didn't have to get back the entire data object from the back end. That's pretty cool. So let's say I want to request the weight now. I'm going to type in weight. And it looks like it automatically added 2 fields for me. So it automatically threw in minimum and maximum for me. So in here, my weight type does not match directly to a data type like float or string. It maps to a type that I have created for minimum, which includes, or for weight, which includes minimum and maximum. So you can see that you can build out queries like this from the front end. Okay? All right, let's pause on GraphQL. So this is the playground. When you get your server up and running, it's already set up to say GraphQL is true when you map it to Express. So you will actually have your own version of this running on your local host. All right, so let's pull up the other one. So GitHub/code Chrysalis/meetup.graphql. So this repository should be public, and you should be able to clone it down. Is it public?
Yes.
Good. Okay. All right. So in here you can see that we ended up using a lot of the same data. So we're sticking with Pokemon on this one. There are instructions for how to set it up. The first step is just to get it running. The second step is to actually develop the schema further. So there is a folder for data. You'll have to end up mapping that to the data. And then resolvers where you can write your own functions to return data. So if we actually look at the code, let's see here. Okay. So here's our code. You're going to have to run an npm install and an npm start to get it running. But if we jump into our index.js file, it should look pretty similar. This is very similar to the slide. So up at the top, let me make it nice and big. We are requiring Express. We are requiring Express GraphQL, and we also have a build schema we're pulling in from the GraphQL library. The data is coming from a different file. So it's coming from a folder called data, and it's called Pokemon.js. So if you open the data folder, you can see what that data looks like. It is the same data as that playground, so you'll see it's got ID, it's got name, it's also got weight, which includes minimum and maximum. So if you aren't sure how to build out your schema, look at this file and see how it is structured in here. So you need to map it the same. If it's a string, make sure you put a string. Okay, so back in my index.js file, if I go to the very bottom, this is what we talked about earlier, which is app.use, which is a function from Express that takes in 2 arguments. The first argument is the string of my endpoint, so /GraphQL. The second argument is where I am mapping it to the schema, to the resolvers, and also setting GraphIQL to true. So that's where I'm saying, yes, I want that playground to play with. If it works, it should say running a GraphQL API server at localhost 4000/GraphQL. So if I do that, I should have my server running. Yep, and here we go. So here's my server. However, if I jump into the docs, I've only got Pokemons and Pokemons only has ID and name. All right, so that's different than the one that I showed you. All I built in your schema was ID and name. So if we go up to our schema, you can see that right here. So I built a schema. There's a type called Pokemon, but right now I've only put in ID and name. I've also made name required and not ID required. You can do whatever you want, all right? Just make sure that whatever you do, you end up using in the resolver functions. In your schema, at one place, you have to put type query. There's 2 things in here, Pokemons and Pokemon, all right? You'll see that Pokemons returns an array of Pokemon. Pokemon itself takes in an argument called name, which is a string, and returns a single Pokemon. If I come down to my root, that will map directly to the resolvers. So back in type query, I have Pokemons, and in my root resolvers, I have a function called Pokemons, which returns all the data, an array of all the Pokemon. The second type of query I had was called Pokemon. It took a name as a string and returned a single Pokemon. If I go back to my root resolvers, you can see that I have a resolver called Pokemon. It expects data in the request. That request better be a name and better be a string or it won't work. And it returns the data of a single Pokemon that matches that name. Okay? So as you build out your schema, you're going to add to the Pokemon type. If you want to add other resolver functions, you're going to have to name it down here, like, I don't know, coffee. This makes no sense for what we're doing, but if you were to create a resolver called coffee, oops, I don't have trailing commas here. So here, up here, you'd have to add coffee and map it to a type. So anything in type query needs to match the name of the thing in the root resolvers, and then everything else would be up here. All right? Advanced requirements, or like advanced things that you could try, is if you get through building out your schema and you get through building out your resolver, and things are great, you can also play with queries and mutations. It's a little different. Call me over if you get stuck, but you'll have to create another type called mutations. And instead of having it called type Pokemon, it would be input something. So there's different language there. But I believe some of that is listed in here. And if not, I'll give you some suggestions of where to look in the documentation. Okay? But you might not get to that part. Okay, it is 8:30, so I'm going to pause. Are there any questions? Okay, so this is the hands-on part of the workshop. You're welcome to stay and play. You're welcome to leave. If you do decide to stay, feel free to work with the person next to you. That's kind of the best way to learn. But we'll go until about 9 o'clock, okay? So we got about 30 minutes, and I'll come around. Raise your hand if you've got questions. Good luck. Thank you.
Thank you.
All right, good luck. Meetup.
なんだったんですか。もう一回やって